Assalamualaikum and a very good day. My name is Muhammad Ariff Iskandar, a student for Mechanical Engineering currently studying Fluid Mechanics 1, and this is a lab presentation for Lab 2 Fluid Dynamics. So, for introduction, we have the Bernoulli's principle here, which states as the speed of a fluid increases, the pressure within the fluid will decrease. So, this statement right here will follow the following equation as shown in the slide here. And then next we will also be looking into the Venturi effect. So this effect states that the reduction in a fluid pressure as a result of the fluid flowing through a constricted section of a pipe. So this statement here will follow the following equation as shown in the slides. So that's for introduction. Let's see the objectives, why we are doing this experiment in the first place. First, we want to experimentally verify the accuracy of Bernoulli's principle, as I just stated just now. And also, we will want to investigate the relationship between the speed of a fluid and the resulting pressure of that fluid. And then finally, we know right now that in theory, a smaller diameter area results in a higher fluid speed, thus having a lower fluid pressure. So that's on the objectives. Next, the actual experiment or the methodology and apparatus setup. As you guys can see in the figure at the top right here, this is the apparatus setup for this experiment where we have a water tank filled with water connected to a venturi tube using a water pipe that has a valve. And then we have a clip right here to control the water flow into the sink we have at the end of the apparatus here. So this part right here, you can see a very close sketch to see how it is actually. So we have the water from the pipe will flow right here. This is tube A, B, and C, and then we have the clip to control the water flow, and then the water will flow into the sink. So first, we will want to prepare the apparatus as shown in this figure right here. And then what we will want to do is to open the water pipe valve right here to allow water to flow into the venturi tube. We will let this happen until the water level inside each tube A, B, and C reaches a certain height, or roughly half the actual height of each tube. And when that happens, we will release the clip at the end here, to allow water to flow into the sink. And then after we've done that, we will want to adjust the water pipe valve and also the clip until the water flow becomes stable. How we know that it's stable is when the height level is static. It doesn't change the height level anymore. So when that happens, we will let that be, and then we will want to observe and record the height of water level in each tube A, B, and C. So that's on the methodology. Next, for the results and discussion, this is the result that we have in this figure right here. What we can say is a larger diameter results in a larger height level in the tube A right here in point 1. As you can see, point 1 has a higher diameter area, thus having a higher water level in the tube. And then in point 2, we have a smaller diameter, so we have a smaller height level in tube B. And then finally in point 3, we have a larger diameter compared to point 2, which is close to point 1. And we also have a height level in tube C which is still higher than in tube B. So what this shows is that as the area or diameter increase, the velocity of the water will decrease inside the pipe here, and so the pressure will increase and vice versa. So this clearly follows the following equation, which is Q equals to VA. So to conclude, as expected, just now I stated as the area increases, the speed of the fluid will decrease and the pressure of the fluid will increase. So we can conclude that pressure is inversely proportional to the velocity in a fluid, and thus Bernoulli's principle is verified. So that is all from me for Lab 2 Fluid Dynamics. Thank you.